Hello and welcome, guys. My name is S1REN with Offensive Security, and today we're going to be working on the machine from Proving Grounds Play, known as Solstice. So what we're going to do is kind of just export our IP and our URL for the target machine. Now I've already done that. So if I echo the IP variable or the URL, assuming it's running port 80, then we're going to be fine. What we want to do is start up an Nmap scan -p-, which is going to cover 65,535 ports. Then we're going to tack on a -sv for service version, -sc for simple scripts on our target IP address, and then --open. Now what --open is going to do, because we're performing a full TCP sweep, so to speak, is it's going to only check the open ports. That's going to skip over the filtered results, closed results, and it's just going to show us what's open. And that'll speed up the process drastically. So I'm going to hit the return key on that. And then once the Nmap scan is finished, I'll unpause the video and we'll go over the Nmap output. I'm going to unpause for a moment just to say there is something we can do to check the status of our scan at any given time. A lot of people don't know if you actually hit the enter key or the return key while it's scanning, that Nmap will give you a status update. Just thought I would toss that in there. And we have our Nmap output. Super. So what we're going to do is just kind of copy all of this output. Just going to select everything. Right-click, copy, and then we're going to move it into Cherry Tree. Now I'm going to go ahead and pause it, and then unpause it once I've moved over all the information, and then we're going to review together a lot of my highlights and what we decided to look at. Alright, so here we are. We're inside Cherry Tree. We've already done a little bit of enumeration. From our Nmap output, we did gather that the target operating system is Debian. We've collected a tight and concise list of all doorways or ports into the target machine. And let's just go through what I've highlighted here. So I've kind of just spared you the time. But 21 is going to be FTP. Now that says PyFTP lib 1.5.6. I'm not sure, but we're going to check it out anyway. 22, Debian. That's where I got the OS information. 25, SMTP, or mail, and some notable commands that we might be able to utilize. Port 80, of course, HTTP, Hypertext Transfer Protocol, and let me just highlight that. And we're going to definitely check that out and see what it has to offer us. Port 2121, another FTP, again, PyFTP lib 1.5.6, apparently hosting a directory called pub. So that definitely warrants further investigation. 3128 HTTP proxy, Squid HTTP proxy. I do plan to go over a machine in the future that utilizes Squid HTTP proxy just to show how we can tunnel out. If the service is running, we can utilize it to tunnel out internal services that are running specifically off of the loopback adapter. That is to say, something like 127.0.0.1 is hosting 22, but it's not to the world. And we want to make SSH open to the world. We can use Proxy Tunnel and Squid to do that, but that'll be for a separate machine. Port 8593, we have HTTP. 54787, more HTTP. Again, these high ports just standing out in each and every engagement. All these high ports are always going to stand out. People thinking that they can hide things from us, it's just a common line of thought. So that's why we perform the -p-. So we get all ports. And then lastly, free float FTP 1.0. Never heard of that, but we could check that out on port 62,524. A lot of FTP, a lot of HTTP, but we're pretty much ready to rock and roll. The one last thing I want to cover here before we start assessing our preliminary enumeration and going over that is that we're going to move SSH to the bottom of our to try list. And the reason for that is because we haven't collected any users or passwords or SSH keys or anything of that nature. So this, as far as priority goes, I mean, we're not getting into that without a little bit of luck and maybe some enumerated usernames. So we're going to put that at the bottom. For now, we're going to stick with 21 FTP, and we're going to start enumerating out. In fact, what I'm going to do, since I see so much of it on this machine, is I'm going to group together each FTP service just to stay organized. And this will help in larger scale engagements when you group down by what the service is. And it's just easier. But let's go ahead and begin our enumeration. So back in the terminal, I've gone ahead and just cleared out the information. Again, here's our IP, our target IP. And I'm going to hop back over to Cherry Tree. And what we're going to do is target 21 and try for something known as root unauthorized access. Or excuse me, anonymous access. I'm thinking more of SQL. But nonetheless, we're going to check for FTP anonymous access. Do we have it? Do we have it? So we're going to just type FTP IP on 21, anonymous, and anonymous. And it doesn't look like we have that. So for FTP protocol, we're going to type bye, and it'll say 221, goodbye. So we do not have that. We're going to move right along to the next FTP, which is 2121. Do we have anonymous access? Let's find out. 2121. Anonymous, anonymous. And it looks like we do. Successful. Great. So let's type dir. And it looks like we have a public directory. So we'll change directory into that. Pub is the current working directory. Code 250. And it doesn't look like we're able to list out anything in here. And if we are able to do that, it's not really coming through. What if we do an ls? Nothing? Well, that's peculiar. Okay, I apologize about the pause there. My cherry tree crashed. But I've gone ahead and redone everything here. It still should be mostly the same. I've even grouped together our FTPs, our HTTPs, and then have SSH down here at the bottom. So we didn't find anonymous access here. Port 2121 is where we left off. So let's FTP back to that on port 2121. And anonymous, anonymous, and we had the pub directory. Now I'm going to type dir and we're not going to get anything back. A common trick in these scenarios is to type the command quote caps PASV, and then we can type ls-lsa, and if we don't get anything from there, then we can pretty much infer that it's just, well, there's nothing in that directory. But what we're going to do per FTP protocol is type bye, and we'll get a 221 goodbye. We'll clear that out, go back, and check that off of our list here for this single target machine. Next FTP, it looks like it's going to be 62,524. So we'll just up arrow on that. 62,524. Hit the enter key. And this one seems to be hanging. Let's give it a second. Sometimes they do take a second. But it might be that there's a little more going on to this FTP port than we realize. To confirm that there's nothing funny going on, let's netcat numerical verbose to the IP on port 62,524. So we didn't get a banner grab, that is to say a netcat banner grab, or an initial TCP connect banner grab that would indicate the service that was running or anything. So that's pretty funny, and post-exploitation, that's going to require a little further investigation. I'll Control Z or Control C out of that. We'll clear this out, and we're going to start saying that this was no connect on that. That was just straight up a no connect. And then we have our HTTP. So we'll start with 80. We'll just reorganize this list so that we go from numerical lowest to highest. Now, when we're checking these HTTP ports, what we're going to want to do is kind of just load up Firefox. Let's grab the IP, and we're going to do, for each one of these, I'm going to copy over the same manual inspection. That is to say, source code analysis. And we're going to follow that up with wfuzz derbusting and parameter testing where applicable. And we're also going to follow that up with nicto. Now there's 3 HTTP hosts on this particular machine. If this was a real engagement, I would advise not running nicto against all 3 consecutively. That's thousands and thousands of requests, tens of thousands, and it could easily inflict some traffic loads and potentially even get you locked out. So if you are going to run nicto across such a wide web surface, it's important to work with your stakeholders and make sure that these time frames are understood, and that well, you don't go over your traffic limits and so on and so forth. But that's the reason we test, isn't it? So port 80 manual inspection. Let's bring up Firefox and let's get this ball rolling. We're going to swing in port 80. Currently configuring the database. Try later, okay. And then 8593. Oh, that looks promising. We are still setting up the library. Try again later. And port 54787. 54787. And this is just a blank page. So we can do some manual inspection, and this is why we do manual inspection first. Because we might actually just find anything, or find something, anything, that shakes loose, quite frankly, without having to be so heavy on the traffic. But with that being said, let's take a look at the source code. There's nothing left behind here. Proudly powered by PHP IPAM. We didn't see that from the front end, so for port 80, I'm just going to add that. And we got that. And thank goodness. So we checked, and we found PHP IPAM. That is something that we would definitely want to check the exploit database for to see whether or not there is or isn't weaponized code. But moving right along, what we're going to do is 8593 next. And this one, let's blow this up. There we go. There we go. So we have a main page. Let's view the page source of index.php. And we have an index call, an href to index.php. Book equals list. Now this immediately stands out to me, just from my professional experience. But to shed light on that professional experience, let's imagine that this parameter we could consider or call suggestive in nature. Let's deem this parameter as suggestive. What do we mean by a suggestive parameter? Suppose we had index.php and we found that there was file equals some file.jpg. That would be very suggestive in nature that there's, because of the parameter name, basically, it would be very suggestive in nature as to what type of data it's processing on the back end. So that's particularly useful information. If you start looking for those things over the years, you'll see something like book, as plain as day, equals list, and it very much is well justified for further testing. So I'm going to get rid of the view source aspect. We're going to close out of that. Click on book list, and it loads list, but nothing really happens. Now the author does say that they're still setting up the library and to try later on, but whenever I go into a dev environment or I've been authorized for that kind of engagement, the first thing that's going to stand out to me is, okay, this is still in development. And because it's still Apologize for the phone. But because this is still in development, we could potentially find something here, very much. And as far as this tab and this port is considered, we don't really have anything. So let's imagine that we know the target is Debian. So if it's running Apache 2, let's just cross-check here. If it's running Apache 2, 8.5 PHP CLI server. Okay, so it's not. But we still at least know the target operating system. Why? Because if it's Apache, the web root would by default be var www html. Okay, so we're going to close out of this tab. It says try again later. And we're going to say that this is the focus. In fact, this is so much the focus of our testing right now that directly beneath the port, for my own convenience as a penetration tester, we're going to just leave that URL there, our little finding that this potentially is just very dangerous. So instead of talking about it, let's get down to testing it, right? Let's say etc, let's try for absolute pathing, etc password. No such luck. Let's try 1, 2, 3, etc password. Maybe a fourth. Nice. Great. So if we right click and view page source, we have a clean output of all the users that exist on the machine. In fact, we have now art attack, and the likelihood of success has pretty much just skyrocketed. We found Miguel. So we don't have to play the guessing game. I'm also going to nano my users file, of which I would like to bring attention to. Whenever I do a single target machine, any files for enumeration purposes, I have a directory for. Any vulnerabilities for weak services, I have a directory for. And I also usually have hashes when going from machine to machine. That way we could maybe move laterally in the network, some different stuff there. But let's nano the users and paste in that we have Miguel out of home Miguel executing bin bash. So that's immediately some information that we've already managed to get back from the target web application. But let's go ahead and continue here. Let's continue right along. There is a little bit of an attack known as log poisoning. Now, I do know that there is an Apache server, to touch on what we were talking about earlier. I know there is Apache running. In fact, Apache is running on port 80. The premise behind this attack is that what we can do is plant, once we've identified the web technology as PHP, we can plant code or poison the log files in an attempt to include it and have native code execution on the target machine. So before we can even do that, though, let's make sure we go to var www html, see if there's an index.php. Sure enough, there is. And that confirms for us, because this is loaded, that we have a very real local file inclusion. Awesome. So let's proceed with our attack to go to the var log apache2 access.log file and hit the return key. Nice. So we see a bunch of HTTP logs here. This is very much looking in our favor. So much so in our favor that I can guarantee you we now have a shell, or we will have a shell. So from this point forward, I'm going to copy this, bring that over to my notes. Why do I do this? What led me to start pasting underneath each port these types of things? Over the years, I've identified as a penetration tester the concept of time management. And if this is the only machine on the network, then I'm going to leave as many notes as I can. But more than likely, in the real world, an organization will permit you or whitelist you for a period of time to, say, a Class C network. That would be something broadcasting on 255.255.255.0. Now let's imagine that we're not the only machine in that network. And let's imagine that we've been given 2 weeks to assess that kind of network, something /24. We need to move along. We need to identify our findings, and anytime we return back to this, we need a direct kind of point of reference. By finding this and having this included at the top of our output, on top of the fact that it's a URL that can be clicked and opened, and on top of the port and the corresponding service, we're pretty well and good for either continuing our attack or going on to reporting. At offensive security, though, one thing we do believe in is the highest level of impact that we can achieve. So what we're going to do is, now that we've verified that this is in fact a local file inclusion, in fact, I'm going to put here that we have a verified local file inclusion vulnerability at the below link. So what we're going to do is plant the idea behind this attack, to draw it out for some of the newer people, is to realize that this log file, apache2 access.log, directly corresponds to the HTTP access logs on port 80. So we're going to perform a netcat connection to port 80, Apache HTTP. And we're going to plant, or poison, the log file with executable code. Let's go ahead and do that. From the command line, we'll clear this out. We'll netcat numerically verbose, or net verbose, sometimes as I like to say it, it's just net verbose. Netcat net verbose to the IP on port 80, actually. And what we're going to do is say something like git / and then we'll open up the native web technology, which is PHP in this case, PHP, and we'll say pass through $_get cmd. Actually, for the sake of this one, let's just make this system and cross our fingers that system is going to work. We'll do $_get cmd and close that and send that along. It's going to say it was a bad request. Don't worry about that. We know what we're doing here. We're going to clear this out. We're going to go back to our browser, and let's go ahead and reload the logs. Now, if we check the bottom, we see that we have a get 400. That was the last log. But we notice that something has been almost truncated from the statement. We don't see our PHP code. This is good. You must remember that this is a local file inclusion vulnerability. And because of that, what we're going to do is tack on and cmd is equal to ID to validate our effective authority and privilege over the machine. That's the first command we would want to execute. We'll scroll to the bottom. Wonderful. So our plan of attack worked, and we now have www data execution on the target machine. Great. We're going to copy that as reference, put that back in our note file. Just the juicier things get, we just keep putting things here. A lot of manual SQLI actually is done this way, by formulating a base statement and building upon it. So notation is also, it's just a good habit to get into. Very good habit to get into. But with that being said, let's go ahead and prepare ourselves a reverse shell. So I'm going to go back to my shell here. I have a command. It's just a bash alias called revshells that cats a file that has the most common and useful reverse shells. I'm going to copy that, and we're going to start working with this statement. I'm going to grab my IP, ifconfig on ton0 adapter, our interface. We're going to copy that, and let's just off the bat do what we can do. Replace our IP, and we'll say that we'll have a netcat listener, netcat-nlvp on 9090. Great. The next thing we're going to want to do is wrap this statement with another bash-c, that is to say, perform the command bash-i and establish a TCP connection. Why do we do this? The reason is because if you were to pull this up, this is kind of a bad character. It's known as a delimiter. And the back-end server technology will interpret that delimiter if we didn't wrap it. And it would just view everything after it as it should, which is a data parameter and a value. But by wrapping it in this, and then also by URL encoding it, we've effectively mitigated that. So I'm just going to put this here. And I'm going to use MayorWeb. You're free to use whatever you like. But let's go to MayorWeb. I use MayorWeb's quick encode decode functionality. We'll URL encode that, Control-C, Control-W to close the tab, and we're good. Now what we're going to do is go back to Firefox with, by the way, this is our full payload, reverse shell payload. I'll put reverse shell payload, both wrapped and URL encoded, and ready for transit or normalized. So let's go back here, and now that we have a netcat listener, I'll remind you, on 9090, we're going to be paying close attention to that. Let's go ahead, and in place of our ID command, we're just going to paste in our rev shell. Let's hit the return key, and it looks like, sure enough, we have gone ahead and received a reverse shell. Wonderful. Now, for any of you that did watch our streams on Twitch, and I will have a word about that at the end of this, but for anybody that watched our streams on Twitch, you know I like to manually go through my enumeration. If you are interested, I did write a blog post or a page. It's SirenSecurity.io, but it's really based off of also Gottmilk's Linux privilege escalation. It's just a condensed guide that I've kind of found the more successful of those checks over the year. I've kind of condensed them together, if you want to check that out. But one of the first things that we're going to want to do here is notice that we have no job control in this shell. So we can confirm that again by typing TTY, and it's going to tell us that we don't have a TTY. That's okay with me. I'm going to open a new terminal, type my breakout command, and we're going to see if Python is here. Thank goodness it is. So we're going to use Python to import a valid TTY. Now if we type TTY, we have it. Awesome. What that means is that if we ever write something to this machine and we need to execute that code, be it for kernel payload purposes or exploits, we now have that functionality. I'm going to export the paths. These are for various distributions that I've collected. Just because I don't like to play around with that, I like to have a checklist of things post-shell. I'm going to alias out the term for color, or export the term as xterm-256 color, alias LL to clear everything from the screen and list everything out, including hidden files, and also include color functionality. And then what we're going to do is confirm that that all works. I'm going to hit Control-Z. And then we're going to use stty raw-echo into the foreground command and into a reset. Why did I do that? I'm also going to exploit this by setting basically lots of rows, lots of columns, no problems there. But what we're going to do here is explain why did we do that. If I hit Control-C now, you'll notice that Control-C is not sending any cancellation, and it's not terminating our shell. In essence, we have a stable shell. If we execute a file on this machine, we're going to have no problem escaping out of it and still existing in our shell, which is great. But I'm going to go here, and I'm going to check out the root file system and kind of just begin my post-exploitation enumeration. We know that there's a user. Let's start that process out of the home directory. So we have Miguel. Let's check out Miguel's directory. What's he hiding? What are they hiding? We have a user.txt, a bash history that's being pointed to dev null, so useless. We have a local directory. Share. Can't go into that. but at least we checked. Is MySQL present? It is. But before we do that, let's just go down our line of enumeration. So, we've checked the home directory. Let's go to var temp. Let's check our world writable directories. Definitely some fun stuff happening here out of the gate. I'm going to come back to it, but what we're going to do is take note that this is directory read-execute with suet permissions. So that was just pure luck. I'm not going to lie to you. But for the newer people, we're going to go to temp is also a world writable directory. Touch data, and you'll see that we have no problem putting data in there as www data. No problem at all. The next thing we're going to do is check dev shem. And it doesn't look like we have anything in here other than squid. It seems like squid proxy decided that it wanted to live out of dev shem, and that's completely fine with me. We're going to go ahead and check the network, netstat-tonlp. And anything off of what we're looking for here. Why do we? When I type this kind of command, what are we looking for? In essence, we're looking for anything off of 127.0.0.1 or the loopback adapter that would not have shown in our external Nmap output. These might be services that we can execute with and play with or exploit. But it looks like there's also something here off port 57. I'm going to include that. In fact, I'm going to put that under other, and we'll call this post notes. We have 127 hosting server, which is pretty interesting. It's not DNS, not 53, so that's pretty interesting. In fact, if I curl HTTP 127.0.0.1 on port 57, what do we get back? Under construction. Okay, so it looks like the developer has a local only web server off of port 57. That's pretty useful information. I'm going to copy that over, and we'll put that as notes here as well. But just continuing right along, let's psaux grep-i for root, -- color equals auto, anywhere there's root. We're going to start at the square brackets and kind of just go down from there. That is to say, from anything mandatory system, we're going to go down. We have cron. I'm going to note that we have cron. So here I'm going to put cron. In fact, there's quite a lot of cron going on. And then this is running, this Python PyFTP is running as root, so that might inquire to some more investigation, right? And then we also have this PHP, this is what we were looking for. I think we just hit the jackpot. So PHP is running -s, a little server off 127.0.0.1.57, and it's living out of the var temp sv directory, which we know that this is a suet directory. So a lot of our post-exploitation enumeration is really pointing to that directory var temp, and we might be able to get something there. So in no means, and by no means whatsoever, is this complete enumeration. This just comes over time. I mean, let's check fstab. Is there extended file attributes or exotic mounts that we might be able to utilize? Let's type mount. I don't particularly see anything here. Nothing with extended attributes. Let's type getcap-r / and pipe any erroneous output to dev null. Nothing came back. I believe that is a lowercase r. I don't think capital R will work. No, it will. Okay, but either way, we've not gotten any extended capabilities left behind by a system administrator. That could be something like giving a language the ability to set UID as an extended permission set. But we've checked that. We've checked the mount. Let's go ahead and check etc. Is there anything here that is not root or root shadow? That is to say, did Miguel or any previous user come along and work with in some way anything out of here We have SMMTA, but that's just the mail. And root LP, but that's going to be, yep, that's cups. So nothing too exotic there. Let's list the permissions on Etsy passwords. Sometimes people like to get clever and have a super lockdown system, but you know, Etsy password, writable, you could write your own user. So, you know, just things to check there. Let's go back to the web root. Var www, and let's take a look. We have a local flag, which is pretty cool. But let's check out the HTML directory. So we do have, it wasn't lying, we have PHP IPAM, which definitely, I mean, we could, what if we cat config.php on this? Try harder. Well, we certainly can, and we certainly will. Let's go back to var temp, and let's check out this SUID. Sometimes I will take you guys through different routes, even though I know the right route, if I believe that it can teach you something useful in the world, if that makes any sense. Let's cd into the SV directory, and let's just take a thorough inspection as to what's really happening here. Type pwd for our present working directory, and it appears that we have read, write, execute permissions across the board. That is for user, group, and other. And that's owned by root. So what we're going to do is we're going to essentially nano index.php. I'm going to press the return key one additional time. It says under construction. We're going to just go ahead and put, we're going to utilize the fact that it is very much under construction. And because this is an intentionally vulnerable machine, we're going to go ahead and, I mean, that's all this web server is doing is printing out that. We're going to say offsec has hello. We would never do this in the real world, but this is just to indicate something later, that the file has changed. This is important, and I'll show you why later. We're going to utilize PHP's system command to perform basically the following series of operations. We're going to copy bin dash to the var temp directory as dash. Then we're going to chain that command together with a semicolon, and we're going to essentially apply chmod user plus suid permissions on var temp dash, and that's it. Now we're going to control X and type Y and enter. And if we're correct, let's cat index.php. Okay, thank goodness it did save, and we have everything here. Now again, this is being run. If we ps-aux grep-i php color equals auto, you will see that again PHP is running out of var temp sv. It's also doing it for these as well. Those would require further investigation, but this one stands out because it's purely local. So what we're just going to do to complete this attack is curl HTTP. We need to, the idea is that we need to view or render the content of the web page, however minimal as it is. But when we do it, we need it to be processed. Like when viewing a page, we know that it's running as root. If we view the page as root, then whatever happens regarding that is going to be executed with root authority. And what did we add? We added this right here. We added an additional system command that when we visit this page, if we had local GUI or graphical user interface access to this machine, we could open up a web browser for context, point it at 127.0, we could just say HTTP 127.0.0.1 on port 57 / and that would essentially be exactly the same thing as just curling HTTP 127.0.0.1 on port 57. If we hit the return key, we've confirmed that our changes to this little file have happened, and offsec says hello. Now let's go ahead and let's go back to var temp. Nice. So there's our shiny That's what I call it. Any SUID sticky bit binary, I just refer to that we can utilize for root. That's our shiny. That's like a holographic card to me. I'm a bit of a nerd, but nonetheless, you'll recognize that terminology from the streams. We could go ahead and execute dash, but it's not going to give us a root shell. That's okay. We can go ahead and just dash p, and that means essentially with the effective authority of root, that is, someone came along and pre-approved this authority, so to speak, by planting the binary here as root. So as that person and within that context, we'd like to execute the dash binary. And that's going to give us root. Nice. Let's go to the root directory, list everything out. Let's clear it first. We could cat the, you would cat your proof.txt. You'd type if config hostname ID. So we have our networking information with a little additional, hostname being Solstice, and our ID is, our effective UID is root. So we have root privilege over this machine. And this is where you would go ahead and screenshot this for your formal report. As such. Nice. Before we wrap up here, guys, this is kind of a proof of concept recording. It's very much, we're running and doing this by the seat of our pants, so to speak. But I'm going to go ahead and conclude the stream by saying that we do have some events going on, and if you ever want to check out what recent products we have at Offensive Security or services, anything going on with the community, from podcasts to these expert AMAs. For example, we have an AMA webinar on the new XP 3112 or Mac OS Control Bypasses course, and that's coming up to be this Wednesday, which is going to be pretty nice. Other than that, though, guys, thank you very much for checking out this video. Again, this was Solstice, and this is available on Proving Grounds Play. If you ever want to register an account, you can totally access those machines. And my name is S1REN with Offensive Security, and I hope you guys have a wonderful rest of your week. Take care.